Hey there, welcome to S.A.F.E, the Society for Advanced and Futuristic Engineering. This is the Astrophysics wing. Ever wondered how astronomers calculate distance to stars? The oldest possible method is called stellar parallax. What is a parallax? Have you ever traveled down the road in a car and looked out at the mountains or hills in the distance? If you have, you've probably noticed that while nearby trees quickly fly past the window, the mountains move much slower, and in the far distance, the moon and the stars don't seem to move at all. This is because of a phenomenon called parallax. Size of the shift depends on the distance you travel along the road and how far away the trees are. The closer they are to the road, the bigger the shift. Same thing happens in case of stars. When the Earth revolves around the Sun, it sweeps in a circle to the nearest star relative to the faraway stars, which tend to remain stationary in the background. So at one part of the year, if you mark the position of a star close to the background stars, and after 6 months have passed, the same star will be seen close to a different set of background stars. You can also observe, closer the star, the bigger the subtended angle. If you can measure the angle at which you moved the telescope in the 6-month process, the distance to the star can be calculated through simple trigonometric relationships. D is the distance of the star from the Sun, and AU is the astronomical unit. For small angles, tan theta equals theta. So, distance is 1 AU divided by theta. Astronomers use the unit parsecs to measure the distance to relatively close stars. Parsec, by definition, is the distance at which a star has a parallax shift of 1 arc second. So let's do some math. 1 arc degree is 60 arc minutes, and 1 arc minute is 60 arc seconds. So 1 arc second is 3,600th of an arc degree. Now 1 degree as we know it is pi divided by 180 radian. Hence 1 arc second is 1 3,600th of pi divided by 180 radians. So 1 parsec, as you can see, is 206,265 AU. 1 AU is the mean distance between Sun and Earth, 150 million kilometers. So 1 parsec is 31 trillion kilometers, or 3.26 light years. So what does this say? The star that can subtend a parallax angle of 1 arc second in the sky will be at 3.26 light years away. So if you know the parallax angle of a star, you can directly relate it to the distance of the star through the inverse proportionality from the equation. Let us do an example problem. The star Sirius, which is one of the brightest stars in the night sky, is 8.58 light years away. What would the angle need to be at in which we would need to move the telescope? You can pause for a while and try the solution. Let us convert light year into parsec. 1 parsec equals 3.26 light year. Hence, the star Sirius is 8.58 divided by 3.26, which equals 2.63 parsecs away. By definition, a star at a distance of 1 parsec has a parallax angle of 1 arc second. By equation, farther the star, lesser the angle. Hence, a star at 2.63 parsecs away has a parallax angle of 1 divided by 2.63 arc seconds. Just 0.38 arc seconds. Hold on, this is not the answer yet. The angle at which you need to move the telescope over a half a year's time shall be twice the angle in the discussion. So, the telescope shall move by 0.76 arc seconds. Nearest star to Earth is Proxima Centauri, which is 4.24 light year away, or 1.3 parsecs away. This will have an angular shift of 0.77 arc seconds. These angles are really small to measure from an amateur telescope. To understand how minute these angles are, consider a protractor, each bar in it denoting 1 degree. The precision we require in an astronomical scale is 1/3600th of a degree, which is kind of a superhuman effort with an amateur telescope. The Hubble Space Telescope now has a precision of 20 to 40 micro-arc-seconds, enabling reliable distance measurements up to 3,066 parsecs, or 10,000 light years. But stars are really, really far, and there are trillions of them. In comparison with Hubble's ability to measure of up to 10,000 light year, our Milky Way galaxy itself is spread across 105,700 light year, and there are billions of galaxies. So this method of stellar parallax can only give distances for a fraction of the stars nearest to our solar system. However, astronomers have developed another method based on brightness of the stars to counter this issue. We will discuss this in detail in the next video. Stay tuned. Please like, share, and subscribe.